After completion of this section, the student shall understand and be able to describe the 4 combustion phases. The combustion process starts when there is an increase in cylinder pressure, and not when the fuel pump starts working. This process can be divided into 4 stages. Ignition delay, uncontrolled combustion, controlled combustion, afterburning. As previously mentioned, it will take a certain time between the fuel is injected into the combustion chamber and the ignition starts. This short period is named ignition delay. Ignition delay is dependent on fuel composition, quality of the fuel, and the quality of atomization. During this time, the fuel will vaporize and react with oxygen until a suitable mixture that will ignite has been reached, leading to the next phase in the process. At the time of injection, the mixture of fuel and compressed air will detonate and result in an uncontrolled combustion. Generally, a large delay between the beginning of fuel injection and when the actual ignition occurs causes a very high rate of pressure increase. A small delay period results in a more gradual rate of pressure increase. The rate of burning is mainly dependent on the ability of the air swirl to bring a continuous supply of fresh air to each burning droplet. This period is characterized such that the sequences such as vaporizing of fuel, reaction with air, etc., are developed at the same rate at which injection is executed. This period begins at the crank angle movement point, where the very steep pressure increase is changed to a much slower pressure rise rate. The combustion will continue a certain period after the injection has ended. This period ought to be as short as possible. This afterburning might be due to different reasons, among others, increased droplet size, larger oil molecular size. Click the keywords to get more information. The beginning of the final phase is denoted by the rapid fall-off in the cylinder pressure following the end of the period during which fuel was injected. Ideally, there should be no afterburning, but it takes place because the mixture distribution is uneven through the cylinder. Heterogeneous mixture. Increased droplet size. If droplet size is increased due to higher viscosity or wear of nozzles, they will penetrate further into the combustion space and may reach the cylinder wall. Oil molecules. The oil molecules may be larger. The possibility for local deficiency of oxygen is much more marked, as the greater molecules have more atoms of carbon, which must go through the process of oxidizing. The result is increased development of soot formation.